Assalamualaikum and good day. So we will continue with the simple example, okay, associated with the potential. Okay, before we start, let me revise what we have covered in the previous lecture. Okay, we covered about the energy exchange involve the charges. Okay, we have two conditions. One is the work done by the system, and the second one is the work done to the system. Okay, so this one internally by the system, and this one is externally, means you introduce the external factor. Okay, then the work done is actually when you want to carry a charge from here to here, and it will have experience a force and also some differential displacement, and work done is equals to vector F force dot vector differential displacement. So this dot product will produce a scalar quantity, which is your work done, and this is work done to the system. Okay, similarly, but if you notice, we apply now external force. Okay, and the charge now is moving opposite directions with respect to the E field. Okay, so the similarly also you have your work done here. Okay, differential work done, F applied force dot dl, but because it is in opposite directions, so you will notice that you will have the similar with this by the system but negative. Okay, due to moving in opposite directions. Okay, so and then you already have learned about the concept of potential difference. Okay, potential difference is from point A to point B is actually the work done to carry a point charge. Okay, so that's why by definition VAB equals to W over Q, and Q is a point charge, so only one. So then you have this and you have this. Okay, and also from the VAB, there you will find that you will have either negative or positive value. If negative, it is the work done by system, and if it's positive, the external force doing the work. Okay, so here V equals to E dot dl, you have to know which coordinate to be used in correspond with the situation. Okay, so for this that we have covered in previous lecture, so definitely this is spherical coordinates. So if you get a condition where cylindrical coordinate is more suitable, so make sure you use the correct coordinate then. Okay, and also you might consider to use Cartesian if it's related. Okay, then you also study about the E with respect to the V, right? So you have VAB is equals to Q over 4 pi epsilon naught over 1 over RA minus RB. Okay, so V potential difference is measured in volts, okay, or joule per coulomb. Okay, then you also learned about the potential, the VAB VB minus VA. So when you have one subscript term, is actually the absolute potential. Okay, what happened is that we want to carry the charge from infinity. Okay, we take the infinity as the reference toward some points. Okay, so when we take the charge from infinity as a reference, our potential, we assume it is to be 0. Okay, so this is the general question. If it's a charge to be carried from the infinity, and this one is considered if the condition if your point of charge is not at the origins. So you can see. Okay, now we go to the practice example 4.2. 4.12, okay? Before we go to 4.12, we go to 4.1 example 4.12, okay? Because it is interrelated, so we need to see this first, okay? So here, example 4.12, 2-point charge, -4 microcoulomb and 5 microcoulomb are located at 2, -1, 3 and 0, 4, -2 respectively. Find the potential at 1, 0, 1 by assuming zero potential and infinity, okay? So here you have 2-point charges, okay? You can rename here the example, rename it as Q1 equals to -4 microcoulomb, 5 microcoulomb as Q2. Then you have this, you obtain this equation as what I shown just now, okay? And because we're assuming zero potential at infinity, so your C is directly 0 and your V is also 0, okay? So the question is asking find the potential, okay? So you have the potential at 1, 0, 1. So your magnitude here, okay, should be a distance, okay, should be a distance from this one to this one and from this one to this one, okay? Of course, you need to match it correctly. This one is 2, 1, -3, 2, -1, 3 is actually referring to the Q1, and this one is 0, 4, -2 is actually referring to the Q2, okay? So similarly, you have V101 is actually the potential that you experience here, okay? So this is actually the Q, the combinations due to the two charges, okay? Then you get it is -5.872 kilovolt, okay? So now we go to the practice 4.12, okay? What the question wants, okay? Let us see first. It mentioned that if point charge 3 microcoulomb located at the origin in addition to the two charges of example 4.12, find the potential at -5, -152, assuming potential at infinity is 0, okay? So you can see the word here can be replaced, this one and this one meaning the same thing, okay? So don't mix it up. So sometimes it's in the equation, sometimes it's in the wording, okay? So if point charge at 3 microcoulomb is located at origin in addition to the two charges, okay, find the potential now. Okay, first, of course, like I told you guys, try to imagine it, okay? Make it into graphical first, so for easy understanding. Okay, if a point charge 3 microcoulomb is located at the origin, okay, now you have a point charge here located at the origin, okay? And because this question is referring, also they refer to the, is related to the previous example with two charges, so it's better that this, the third charge, we label as Q3, okay? And it is at as 3 microcoulomb, okay? In addition to the two charges of example 4.12, okay, the two charges of example 12 is one is at 2, -1 and 3, okay, 2, -1 and 3. We can imagine it's here for Q1, which is -4 microcoulomb. The coordinate is 2, -1, 3. And the second charge from the example before is actually at 0, 4, -2, okay, here. So here is your Q2. which with the charge of 5 microcoulombs, and the coordinate is 0, 4, -2. Okay. So we have settled for this one and this one in the example 4.12. However, now we need to use some information that we have gained from example 4.12 to solve for practice 4.12. We will use some information on the example 4.12. Okay. So this one is at the page of 147 of Sadiko. Okay, you guys can read later on for further details, and from the beginning of page 144. Okay, for potential, you can read a lot. Okay, it's more detail there. Okay, so now the question is asking at the for practice 4.12, find the potential at -1. What is the potential at -1, 5, 2? Okay, first you locate where is your -1 here, -1 here, 5 and 2. So we can we imagine it is somewhere here. Okay. Okay, this is the, we will measure the potential here. Okay, and by assuming V at potential infinity is 0. Okay, so certainly when you do this calculate, you should know that your V, okay, your potential with respect to different locations, okay, of R is actually contributed by these three. Okay, so you have V1 plus V2 plus V3. And for simplicity, you know V is actually Q 4 pi epsilon naught equals to magnitude of R. For example, we can use here, is K. Okay, and is it complete equation? No, it is supposed to be summation. Okay, from here, then it is from K equals to 1 to 3. Okay, and some constant. Okay, so when you have V approach to infinity, okay, when your potential at infinity is 0, so your C will be 0. Okay, now for this condition, you need to know the magnitude. This magnitude is different because we have 3 locations now. Our charges is at 3 locations. We have 3-point charge. Okay, first you have R minus R1. Second, you have R minus R2. And third, you have R minus R3. Okay, so what is your R here? Your R certainly is this value. Okay, so minus the point of 1 here, you have 2, -1, 3. Similarly here, -1, 5, 2, minus 0, 4, -2. Okay, and then for your R3 is actually this 1, 5, 2 minus origin. Okay, so it's 0, 0, 0. Okay, so you solve this. For example, if you get the value is x prime, here the value is x, you can use x1, x2, x3. Okay, just put it in unknowns. Okay, unknowns. You guys can calculate your later on. First, I just want to show the working concept. Okay, then your V potential experience at this location is actually your Q 4 pi epsilon naught 4 pi epsilon naught and this condition. Okay, but you have 3, right? Because it's contributed by the 3. So you have 1 over x1 plus 1 over x2 plus 1 over x3. Okay, sorry, it's a superscript, it's a subscript. Okay, so what then is your Q here? So what will your Q here? Is it related with this one? Or is it a single value? Certainly it's a with respect to this value. So your Q here is actually your Q1, your Q2, and your Q3. Okay? This one, 4 microcoulomb, 3 microcoulomb, and 5 microcoulomb. And because all of them is sharing the same unit, micro, so you can use just here to put like micro here. Okay, so this one is your -4 microcoulomb, 5 microcoulomb, and 5 microcoulomb. So you get your answer, and it can be in the unit of volt. Okay, this one is certainly correct, it's famous already. Or the second is, what is the other unit that you can use to represent your voltage? Is joule per coulomb. Again, by definition, what is V? Potential. Potential difference is actually the work done to carry one charge from one point to another. Okay. Okay. So we will cover the next lecture of the slide, the next lecture in part 3. Okay. Thank you.